Hello, I, Dr. Prabal Chakraborty, Associate Professor of Jagannath Institute of Management Studies, presenting you a series of lecture subject Business Statistics, and the topic is Central Tendency. We will cover mean, mode, median as a part of the central tendency, quartiles, variations of the data, range, variance, standard deviation, coefficient of variations, and skewed data, symmetric data, as well as whisker plots, as well as coefficient of correlations. Meaning of arithmetic means. Here the data are given. We have to how to find out the arithmetic mean of a data. Here the data are given like this. Sample means if the data are given like this 2 plus of 3 plus of 4 plus of 5. These are the 5 data are given. If you want to find out the mean, how many data are there? 1, 2, 3, 4 divided by 4, that is equal to how much? 5 plus of 4, 9, 9 plus of 3, 12, 12 plus of 2, 14, 14 divided by 4, that is equal to how much? That is equal to 3.5. Means similar, it is a simple, we should take the xi, sum of xi divided by number of data. So suppose the populations of a mean means we have to take the population of different x1, x2, xn and divided by n, that represent the populations mean, and x bar is the sample mean, it is represented by this. A sample mean is represented by x bar and population mean is represented by mu. It is very important, it is will be used in future also. Next is that the means, the most common measure is the central tendency, means mean is the most commonly used. It is act as a balance point, means it is a center point. Somebody states like that, it is a center gravity, it can be stated like that. If it is extreme values are different, then the means will shift it. You see here the extreme values are 1 and 9, therefore 9 plus 1, 10 divided by 5, that is the mean, divided by 2 is the mean. If the extreme values are 1 and 14, the extreme values means 14 plus of 1 means how many data are there, on that basis that can be mean can be 6, means it is depends on the extreme values. Okay. Now median is the center where it will divide equally both the ends. Say here 5 data are given, means 2 one end and 2 and another end, then it is called as a median. It is also a part of the central tendency. If the number is odd, then the the median is given by n plus of 1 divided by 2 is the median. I hope it is clear to you. Okay, means how many data are given? There are 5 data, means 5 plus of 1, that is equal to third item, means third item would become 5 is the third item. Similarly here there are 5 items, therefore median is okay. It depends on the median is odd or even, we can find out that. Okay. Now mode means it is mode is the point where largest repeated number, most often numbers, that is here the 9 is repeated thrice, therefore mode is the 9. But here if you see none of the numbers is repeated, that's why no mode is there. Okay, you should be very sure about this, means largest repeated number is represented by the mode. Okay. Similarly, geometric means if the say 4 and 6, if we want to find out the geometric mean of a two numbers, means 4 into 16, that is equal to 8. If it is used in population etc., then how to find out the geometric mean? Always you should remember that arithmetic mean is always greater than the geometric mean. Arithmetic mean is always greater than geometric mean. What actually I mean to say? x1 plus of x2 up to xn divided by n must be greater than equal to x1 into x2 into xn whole to the power 1 by n. That I mean to say. Means arithmetic mean is always greater than geometric mean. It is used usually in population etc. indexes. Okay, when the percentages are given, in that cases we should use this. Okay, now compound formula in compound interest, we have to find out the compound interest. If the rate of interest is vary, if it is change, it will change. If the rate of interest first year is R1, R2, R3 like this. Now, if you want to find out the geometric mean, then what would be the rate? Then we should take the formula like this. Okay, I hope it is clear to you. Now, actually, how to find out the amount means when the principal is given and rate of interest is given and time is given, then this is the formula that would be used for finding the final amount. And this is the A is the original amount. That in some cases it is represented like this. A is the amount is represented by P1 plus of R whole to the power n. But here I have mentioned like this. Okay, no problem at all. Here A stands for amount, P stands for the principal, R stands for rate of interest, and N is the represented by time. Now, suppose an examples, it would be very clear to what actually the difference between the arithmetic and geometric mean. If the average rate of return decrease by 50% and another it is increased by 100%, say in this example what actually it is, the average, how much average that has been increased, that is equal to, you have to add this 2 divided by 2, that is equal to 25%. But in geometric rate of return, if it is what actually we have find out arithmetic rate of return, geometric rate of return, what would be happen? 1 minus of 50 by 100, 1 plus of 100 by 100 whole to the power 2, means what will happen? This will become 1 plus of 1, that is equal to 2, this is 1 plus of 1, that is equal to 2, and 1 minus of point, that is equal to 0.5. In 0.5 into 2, that is equal to 1, 1 minus of means there is no return. Is it so? But you have to be very careful when you will finding the returns. Now, range means if it is what actually it is extreme ends, means if the numbers are given like this in ascending order 2, 3, 5, 7, 11 etc., then the range is 11 minus of 2, that is equal to how much? That is equal to the 9. Now, mid range means 2 plus of 11, 2 plus of 11 divided by 2, that is equal to 13 by 2, that would be the mid range. Okay, means extreme ends, smallest as well as largest. Okay. Now, quartile means as median divide in equally, here it is quartile, first quartile is 25%, second quartile is 50% of the data. Okay, and third quartile, that is equal to 75% of the data. Now, that would be the observation is 25% observation, that is 50% of the observation, and this is 75% of the observation. How it is calculated? N plus of 1 by 4 means n is the number of data, 3n plus of 1 by 4 is this is the first quartile, and this is the third quartile, and the second quartile is represented by 2n plus of 1 by 4, that is equal to n plus of 1 by 2, that is equal to, that is why it is equal to median. Okay. Now, so this is an example, Reliance Securities. Okay, collect the following closed stock prices of the new stock 1716 like this. What is central tendency and variations of using the quartile? First, you arrange in ascending order, smallest to highest, and thereafter we can find out the central tendency as well as variations we can find out using the quartiles. First, what actually I have told you, arrange in ascending order, arrange in ascending order, and second, find out quartile, second quartile and third quartile. that are the central tendencies. Suppose this is the example which I have expressed earlier. First quartile is 25%, second quartile is 25%, third quartile is also 25%, and fourth quartile is 20%. First quartile, how it would be represent, that I have mentioned you, that is equal to n plus 1 by 4. Second quartile like this. Now what actually I have told you, you have to arrange in ascending order, means ascending first quartile will become 2.5, means average of 12 and 13. Then what would be the average of 12 and 13? That is equal to 12.5. This would become the first quartile. That is equal to 12.5. If you want to find out the third quartile is 3n plus 1 by 4. 3n plus 1 by 4 is equal to the average of 17 and 18, that is equal to 17.5. And the median, that is the n plus 1 by 2. How many numbers are there? 9 plus 1 divided by fifth. Fifth is the fifth, means first, second, third, fourth, fifth, means this would be the median. I hope it is clear to you. Range. Now interquartile range is represented as Q3 minus of Q1, that is called interquartile. Third quartile minus of second quartile. You have to find out the third quartile, that we have find out 17.5 as in previous question, that is equal to 17.5 is the third quartile and the first quartile is represented by 12.5, that is your first quartile, that is equal to 12.5. Interquartile range is 17.5 minus 12.5. Now sample variance, which is represented by a square and divided by n minus of 1, means number of dependent variable is represented by n minus 1, whereas population variance is represented by xi minus of n. Mu is the population's mean. You should be very careful. One is population variance and another is the sample variance. Number of independent data is n minus of 1, and here in this case population means we have to divide by n. Now what actually the variation means, if the data are like this. Now if I draw a line, means here the variation, if the data is in these lines, means in this case variation is large, in this case variation is large, but here variation is equivalent to 0 if they are in the same straight line. Okay. Now comparing the standard deviations, here the what exactly you have seen, that case standard deviation is 3.388, 3.98 and 4.1. See here in data B, the variation is very small as compared to A as well as C. See, if you compare the variation of B, means all data are 14, 15, 16 and 17, but whereas in the C and A, the data are spread to 11 to 21, therefore variation is large. Means as much variations, the variation of the data means data are, if it is not evenly be plotted, then the variation would become high. If it is evenly plotted, then the variation is less. From here you can easily compare why this variation will come, because here you will see that 14, 15, all the data are in the 14, 15, 16, 17, but here the data are in different position, that is why. Okay. Now what is coefficient of variation? Coefficient of variation means standard deviations divided by mean into 100. That is called coefficient of variations. Say Tendulkar's coefficient of variations is 60%, whereas here it is Tendulkar in a cricket match, and Dhoni it is 30%. It is for the Dhoni. Now who is consistent? Who is consistent means whose coefficient of variation is less, means coefficient of variation is less, then he is more consistent. He is more inconsistent. He is inconsistent. What actually the coefficient variation indicate? Consistency of the data, and he is consistent. Okay. On that basis, we can compare the two data whether it is consistent or inconsistent. Skewed data. Skewed data, what is actually what is it? Is leftly skewed or rightly skewed, or it is evenly skewed. See here, if it is leftly skewed, then the mean in this one end and mode is in other end and median is in the center. Similarly, mean, mode, median in the same point, all are in the same point. Okay, all are in the same point. Therefore, they are symmetric. It is a normal curve. It is skewed at the left and it is skewed of the right. But here you see that the median is the middle, mode and mean in the other extreme. But in the left, skewed mean in the left and the mode in the right. But in the right skewed, mode in the left and mean in the right. But median in all the cases are at the same. But in the symmetric, mean, mode, median in the same place. Here graphically displayed by the box and whisker plots that how mean, mode, median and quartiles are placed, that has been mentioned here. It is leftly skewed as I have explained to you in the previous slide, where the mean, mode and median to be played. This is first quartile, this is first quartile, this is second quartile, that is median, and this is third quartile. Similarly, if it is quartile, if it is a symmetric, means it would be the median. This would be the point that is called median. Okay. But if it is a rightly skewed, this is quartile area, this is quartile area, and if it is quartile, that is the median. This is nothing, that is the median. Okay. This indicator shows where is your median. This is the indicator when you will do SPSS. In there you can easily understood box or square plot that you can find out. Okay, this is all about the central tendency, what exactly we have discussed. Now in details you will be discussed in the class also. You attend the class regularly, then you will understood. Now next is that correlation. When relation between the two quantitative data we can compare, then we should use correlation. The formula is given by xi minus of x square, y minus of y bar divided by xi minus of x square whole square by. It can be written as covariance of, you can do it like this, covariance of x and y divided by standard deviation of x into standard deviation of y into it. Okay, it can be written like this. It is correlations, that is negatively, perfectly negatively correlated. It is negatively correlated. There is no correlations. If r is equal to 0, no correlations. And it is positively correlated, and it is perfectly positively correlated. Perfectly. This is also perfectly. This is also perfectly. This one also perfectly. Okay. Perfectly means r is equal to -1, and if r is equal to 1, the value of r correlation is always lies between -1 and 1. If r is equal to 0, no correlations. Okay. That what actually I have explained to you, the correlations value is lies between 1 and minus of 1. It is -1, then perfectly negatively correlated. If it is +1, it is perfectly positively correlated. Means if it is lies between 0 to -1, it is strongly negatively correlated. If it is lies between 0 to 1, it is strongly positively correlated. And is equal to 0, there is no correlation, means it is very weaker correlation. Thank you very much.